All right, so we have dealt with a lot of cases of forces in very simple situations. The simple situations being what happens if we're dealing with a flat surface. Well, not everything in this world is flat, so we are going to deal with what happens if we deal with forces on an incline. Here I have my inclined plane, and sitting on my inclined plane is my object. All right, gone ahead and drawn my object as a box. All right, we're going to go ahead and identify some forces acting on this box. We have our center of mass where we draw all of our vectors from. That's the center of our box. And we're going to look at the fact that our object has, first of all, weight, which acts straight down, and then it has a normal force, which acts perpendicular to the surface. This is always, always, always true about the normal force. It is always perpendicular to the surface that our object is on. All right, so I have my weight, I have my normal force. Typically, when we're looking at what's going on with our objects, we have dealt with our axes being straight up and down and straight across. However, if we were to do that here, it would make our lives a lot more complicated. We can simplify our lives by looking at the fact that all of our motion is going to happen along the surface of our ramp. Because of that, we can simplify our lives a lot more. We're going to go ahead and set up our axes as, wrong direction, perpendicular to our ramp and parallel to the surface of our ramp. All right, this is going to be my positive y-axis, and this is my positive x-axis. All right. Now, when we have worked after this, we applied Newton's second law into each individual dimension. We looked at the sum of the forces in the y direction, and we looked at the sum of the forces in the x direction. Well, looking at our forces here, the normal force is going to cooperate pretty easily. The normal force is entirely in the y direction. Our weight, however, is not. Our weight is dealing with something a little bit different. All right. Our weight is in both the x and the y direction, so we're going to go ahead and break that into x and y components. Our y component being perpendicular to the surface of our ramp, and our x component being parallel to the surface of our ramp. And I'm going to go ahead and label those. This is my x component of my weight down here, and this is my y component of my weight over here. We need one more piece of information. We need a couple more pieces of information. We know, first of all, the fact that the angle between our x and y axes will always be a right angle. All right? That's a definition of a lot of things. We do need to know one more piece of angle in order to get the full picture of what's going on with this. We have this angle down here labeled, all right? And fun fact, with a bunch of geometry proofs and all that fun stuff, that angle down here is actually the same as the angle in here. So that theta here is equal to this theta here. All right, because chances are you are going to be given the angle of your incline. From here, we have two equations we can write. This is going to be true for all cases. All right, and that is the fact that yx is going to weight x is going to equal to our weight times sine of theta, and our weight in the y direction is going to be equal to our weight times cosine of theta. From here, everything that we're going to be doing with our forces on an inclined plane problems is going to be based on the information that we see here.